So I will be doing page 43, question number 6. And the question is something along the lines of asking us that a rock is thrown up a hill at an incline of 30 degrees, and the rock is thrown at a velocity of 16 meters per second with 65 degrees to the horizontal. So we're supposed to be looking for the range at which it lands on the hill. So this question is a little bit difficult because we have an incline. The rock is not going to land at a displacement of 0. It'll be landing at some height over here, and there is an incline, which makes this a bit difficult, but we can solve this. So we're going to write down our givens first. We know that the acceleration due to gravity is equal to 9.81 meters per second squared, up. We're taking up as positive. We know that in the question they said that v1 is equal to 16 meters per second, and it's at a degree of 65 degrees to the horizontal. We know that the hill has an incline of 30 degrees, and we also know that when this rock lands, its time will be the same horizontally as it will be vertically. So we can see that we have a right angled triangle here. So we can easily say that our x component, our horizontal component, squared plus the vertical component squared will give you our range squared. So that is what D is going to be. D is going to be our answer that we're looking for here. So let's go ahead and solve for some other variables, which we can right now. We can do v1 x and v1 y. And v1 x will be equal to 16 times the cosine of 65. And v1 y will be equal to 16 times the sine of 65. And these values approximately equal. We have 6.76 meters per second to the right here, and we have 14.5 meters per second here. So we can start off by writing out equations, because first we're going to be solving for this value and this value over here. So we can also say that what is our dx and what is our dy value. So we can start off with our vertical direction, and we can write dy, and we can use our first kinematics formula, which is v1t, v1yt plus 1/2 at squared. Now we can input our variables that we know here as 14.5 t plus 1/2 negative 9.81 t squared. We can also write an equation for dy, which is equal to v1x t plus 1/2 at squared. Now here, this part can be crossed out because in the horizontal direction there is no acceleration. This velocity over here will remain constant. So we can go ahead and just input values over here where we have 6.76 t. So we have, oops, I wrote dy two times. Sorry about that. Oh, here. Okay, so we have dx over here equaling to this, and we have dy equaling to this. Now, to get these to equate and equal each other, we have to look at this as a triangle. So we have 90 degrees here, we have 30 degrees here. We know an equation for this, and we know an equation for this. We can write this as a trigonometric function of tan 30, as tan is usually the opposite over the adjacent. The opposite in this case is dy. The adjacent in this case is dx. So that's what tan 30 is. Now, if you remember your special triangles, you can draw it out here. And we'll use the one where it goes as the hypotenuse is 2, then we have 1 and square root 3. And our angle is 30, 90, and 60. So if you look at our special triangle here, we have 30 over here. So we're going to look for the tan of 30. So the tan of 30 is the opposite over the adjacent. So we have our values here, and we can replace tan of 30 degrees with these values here. We can write 1 over root 3 is equal to dy over dx. Now we can just cross multiply and get rid of the denominators and write dx is equal to root 3 times dy. Now that we have an equation here, we can actually substitute dy with this equation and dx with this equation. So we can go ahead and do that over here and write 6.76 t is equal to 14.5 t plus 1/2 9.81 negative t squared multiplied by the root 3. And now we can go ahead and solve for t. So I'm just going to write down what I have in my notebook here, which says that 6.76 t is equal to 25.11 t minus 8.5 t squared. Now we can move everything over to one side and write that 18.35 t minus 8.5 t squared is equal to 0. We need to now isolate for t, and we can do that by factoring out 1t over here. And now we can go ahead and solve inside the bracket over here. So we know that 1t is there's going to be two answers for t. One answer for t is 0. The second answer for t will be equal to, and we can do the whole equation here if we want, 18.35 minus 8.5t equals 0. So we can write 18.35 is equal to 8.5t. In this way, once we divide 18.35 by 8.5, we get an answer of 2.15 seconds. Now, which answer for time do we use? Do we use 0 or do we use 2.15? Well, we don't use 0 because if we use 0, our distance would be over here, and this is not where the rock lands. This is where the rock starts. We want the distance over here, so we have to take the time after, which is 2.15, and this seems like the most plausible, so we're going to be using that time. Now that we have t, we can replace it in one of our other equations. So I'm going to go ahead and put it in this equation, and we can write dx is equal to 6.76 t, and rewrite t as our 2.15. And we get a value for d of x. That value is 14.5 meters. Now that we know that, now we can input that and find dy here. So we can just rewrite this as dx over root 3 is equal to dy. So dx is 14.5 over root 3 is going to equal dy. dy, therefore, is equal to 8.42 meters. So now we have a value for dy and a value for dx. If we look at our diagram over here again, we found a value here. We find a value here. We need to now find this value. And if you remember your triangles, you also know that you can find that simply as the hypotenuse, which is a squared plus b squared equals c squared. So we can take d as our c squared, or our c, and we can set that equal to the square root of dx squared plus dy squared. Now we can input our known values, which are 14.5 squared plus 8.42 squared, and find the square root of that. Our answer, finally, comes out to be around 17 meters if we round it off. And that's it. This is the answer. You don't need to find your angle for this because the angle is already given to you in the question, and all they want you to do is find the range as a scalar.